You're doing some stress testing of various models of glass jars to determine the height from which they can be dropped and still not break. The setup for this experiment on a particular type of jar is as follows. You have a ladder with n rungs, and you want to find the highest run from which you can drop a copy of the jar and not have it break. We call this the highest safe run. It might be natural to try binary search, drop a jar from the middle run, see if it breaks, and then recursively try from run n over 4 or 3n over 4, depending on the outcome. But this has the drawback that you could break a lot of jars in finding the answer, which might not be good. If your primary goal were to conserve jars, on the other hand, you could try the following strategy. Start by dropping a jar from the first run, then the second run, and so forth, climbing one higher each time until the jar breaks. In this way, you could need a single jar at the moment it breaks. You have the correct answer, but you may have to drop it n times rather than log n as in the binary search solution. So here is the trade-off. It seems you can perform few drops if you're willing to break more jars. To understand better how this trade-off works at a quantitative level, let's consider how to run this experiment given a fixed budget of k greater than or equals to 1 jars. In other words, you have to determine the correct answer, the highest safe run, and can use at most k jars in doing so. A. Suppose you are given a budget of k equals to 2 jars. Describe a strategy for finding the highest safe run that requires you to drop a jar at most f of n times for some function f of n that grows slower than linearly. In other words, it should be the case that the limitation of fn over n, where the limit take for all n goes to infinity, is equals to 0, which means that fn grows slower than linear. B. Now suppose you have a budget of k greater than 2 jars for some given k. Describe a strategy for finding the highest safe run using at most k jars. If fk of n denotes the number of times you need to drop a jar according to your strategy, then the functions f1, f2, f3, and so on till should have the property that each grows asymptotically slower than the previous one. That is the limit of fk of n over fk minus 1 of n, where the limit takes for all n goes to infinity is equals to 0 for each k. So for such two problems, for k equals to 2 jars, our answer is the square root of n times. And for k greater than 2, then the answer is the kth root of n times, which means that if we take the limit, the kth root of n divided by the k minus 1 root of n is 0 if n goes to infinity if we take the limit. What's your answer?